Okay, now we'll continue with example 3 and 4. Suppose that pulley arrangement is 95% efficient and is used to raise a 3900 Newton engine block to a height of 1.3 meters. What work in is required? Okay, first we need to figure out how much work out. So how much is it to lift the block without any assistance if we just had to lift it straight up? Well, work is force times distance. Force required to lift the block, we were told, was 3,900 newtons. It has to be lifted a distance of 1.3 meters. So the amount of work required is 5,070 joules. Now we know the efficiency is 95%. We know the work out, we need to figure out the work in. So we put in our efficiency, we know the work out, and we have to solve for work in. So efficiency, we don't write 95, remember it's a percent, so decimal 95. The work out is 5070, and work in, so we'll cross multiply and divide by 0.95. That's just solving the algebra. You folks should have no difficulty with that. And when you complete the math, it would take 5,337 joules. Tip here when you're doing this, your work in should always work out to be higher than the work out. So the work out without any assistance is 5070. Using a pulley system, it's 5,337. So this should always be higher. So it should always be higher than work out. Right, on to the next example. So here we have a wheel and axle, and it's being used to lift a bucket. It's estimated to be 75% efficient. What work out is obtained if a force of 250 newtons is used to move the outer part of the wheel. So to use this system, this advantage, to lift that bucket is going to require 250 newtons. So that has to be our work in, because we're using this to lift the bucket rather than lifting it hand over hand just by the rope. So if the bucket's too heavy to lift by yourself, you use this wheel and axle. As you turn it, you lift up the bucket. What it's asking you to do, if we've done it without any assistance, what's the work out? So the work into the system, it took a force of 250 newtons to turn the wheel, 0.82 meters. So if you think about the distance you turn the wheel, the circumference that you turn it 0.82 of a meter as you're rotating it around, and it would take 205 joules. And now that you have the work into the system, use the same formula for efficiency, and now you're going to solve for the work out. So we know the efficiency, 0.75. The work out we don't know. It's going to take 205 joules just to turn the wheel around. So here if you cross multiply, you'll find that the work out will come down to 150 joules. And remember, as we said before, the work out should always be lower than the work